Let's now look at the concept of tangents from a point outside the circle. So here you have your circle x square plus y square equal to a square. You have your straight line y is equal to mx plus c. You have this point x1 y1 which is outside the circle, right? You need to find that tangent which passes through this. So how many such tangents are possible? That is the question, right? The answer is 2 tangents are possible. One is the one that I've drawn. The other can be something like this. So there are 2 tangents possible outside of, from a point outside. So how do you find out? How do you find out these tangents? So you assume a line y is equal to mx plus c. You've taken a straight line, and if that is to be a tangent, then we already know that the condition is c square is equals to a square m square plus a square, right? A square into m square plus 1. So c is equal to plus or minus under root a into under root a square m square plus a square. This is the condition. Now if I take both plus and minus, you might get a doubt that okay, if I have 2 tangents, then plus should correspond to one, minus should correspond to another. But the answer is no, right? Because plus and minus, that is the case where you have 2 perpendicular tangents. So like something like this and this. So this pink line and this blue line, these are perpendicular. For this you have plus or minus, not for this, because for this pink line and this blue line, they have the same slope, right? They have the same slope. But here, as you can clearly see, these 2 lines have different slopes. So how do I find this? So I'll just pick up one of them, maybe the one with a plus. So I've picked that up. Now I'll make this line pass through this point x1 y1. So how will I ensure that? I'll put x1 y1 in this particular equation, right? Now as you can see, I have y1 is equal to mx1 plus a into under root 1 plus m square. I can take mx1 that side, square on both sides, and if I square and rearrange, I'll get a quadratic in m. I got a quadratic in m. Now solving this, I should get 2 values for m, right? I may or may not, but at max I can get 2. Let me assume that I'm getting 2. That would mean these two lines or these 2 values of slopes correspond to those lines which are tangent to the circle and are also passing through this point x1 y1, right? Because it's passing through x1 y1, that I've already ensured because I put x1 y1 in the condition, and it is a tangent because I've ensured that my c is equal to a into under root 1 plus m square. So both the conditions are ensured. So it is a tangent and it is passing through x1 y1, right? If I get 2 values, for instance, if the discriminant of this quadratic is 0, then I'll get coincident lines. I think both my lines will be the same. That means from that given point you can have only one tangent. And if my discriminant is less than 0, then in that case only one tangent will be possible. In that case no tangent will be possible because there will be no roots for this equation, right? So that means there will be no line with a defined slope which will pass through that point. So it all comes down to playing around with quadratics, right? Playing around with the roots of a quadratic equation. This was the concept of tangents from a point outside the circle. Let's move on to the next subtopic.